My name is Gurpreet and I am a PhD scholar at Indian Institute of Technology, Delhi, India. I am very thankful to the organizer of ERP 2024 allowing me to present my research on the topic of a computational approach for the modeling of diabetic foot ulcer progression. So diabetic foot ulcer is one of the most prevalent foot issues for the patient with prolonged diabetic conditions. So medical case studies on the diabetic foot ulceration have been reported in the literature, but the understanding from the biomechanical aspect is limited to it. So in my research, I have focused to study the effect of standing loads on the plantar fascia of the diabetic foot, considering the individual ulcer on all the possible locations. So in this research, a full-scale human foot model was created to investigate the effect of all possible ulcer location on their possible progression and potential re-ulceration. So there are the three basic steps, starting with the geometrical modeling, finite element meshing, mesh convergence study, and then in the simulations. So subjected to the standing load, the material properties were selected as optimal properties with the bones and the soft tissues in diabetic conditions. For table 1 is showing the material properties simulating the diabetic foot. We have used the circular geometry for the making the ulceration with the diameter of 16 mm and the depth of 5 mm. So figure 2 here is showing the 52 ulcer location marked along the x-axis and the y-axis, that is the length and the width of the foot. So the developed foot model has a total of 52 ulcer locations that were simulated separately. So plantar stress distribution, peak stress, and the peak stress location and the stress is induced at the four corners of the wall of the ulcers were quantified. So 4 foot ulcer resulted in the concentration at the corners of the heel, indicating possibility of the new ulcer formation. The midfoot and the hindfoot ulcers induced low and high stress concentration at the wall respectively. So ulcer location at the hindfoot experienced a significant increase in the maximum plantar stresses, ranging between the 0.72 megapascal to 1.33 megapascal, that is approximately 20 times, indicating the chances of enhanced ulcer growth progression. So figure 3 is the representative hormesis stress simulating of the diabetic foot ulceration. So these are the results of the ulcer wall stresses and the possible growth directions. So summarizing, there is a diabetic foot ulceration at all possible locations were studied and their effect on the generated plantar stresses were characterized. This work was the first attempt to date at the characterization of the effect of ulcer location on the diabetic metastasis, predicting the ulcer growth and the new ulceration across any foot model. So I'm very thankful to the Ministry of Education for providing me the Prime Minister Research Fellowship for conducting my research and funding to attend this conference. So these are the references for this article and thanks.